Hi everyone, welcome to my channel. Today in this video we are going to learn about 7 segment display. Here you can see we have two types of 7 segment displays. One is common anode and the other is common cathode. The difference between common anode and common cathode is here the terminal is connected to VCC, that is power, in common anode. In common cathode, if we see, it is connected to ground. This is the main difference. So in a 7 segment display, we have total 8 LEDs, which are represented from A to H, or last one is H, or it is also called as DP, decimal point. You can say it as decimal point, which is used only when we are going to represent any decimal values. So DP or H is for decimal point, which is usually when we are using 7 segment display to display 0 to 1, 0 to 9 values, this DP value will be always off, remaining A to G. So in common anode, all LEDs are on when we pass 0. LEDs will be off when we pass 1, value 1. So here you can see based on that we have created a matrix. So here we have a table based on that, which are for 0. What are the values should be on? What are the values should be off? What are the segments should be off? So in 0, H and G are off. That is, H means DP, decimal point, and G. Remaining all will be on. So A, B, C, D, E, F are on for 0. So for common anode, 0, if we pass value 0, the LED is on. If we pass value 1, the LED is off. So based on that, we have developed this table. So 0, 1, here digit. This is our digits. So for D0, this is the value. So if we divide, this is the binary value. If we convert it to hex, 1100 is C, 000 is 0. Same for 1, only B and C are on, remaining all will be off. So B, C are on, remaining all ones because they are off. If we convert it to hexa, 1111 is F, 1001 is 9. So in the same process, we extract our hex values for common anode. For common cathode, if we see here it is exact opposite to common anode. So if we pass 0, the LED is on, the LED is off. For common cathode, if we pass 0, the LED is off. If we pass 1, the LED is on. So the values will be exact opposite to common anode. So here 0 is off, 1 is on. So if I want to 0 have value should be on, displayed, 0 value should be displayed. I have to on the A, B, C, D, E, F values. So it is 1. Remaining all values 0. For 1, BC has to be 1. Here you see BC has to be 1, remaining all zeros. So if we convert it to hexa, all 0, 0, 0, 1, 1, 0, 6. So in this way, we can draw all our hex values for common cathode. These are the hex values for common anode. These are the hex values for common cathode. So this is the basics of 7 segment display. Here these A, B, C, Ds represent our LEDs. So if we pass our hex values to this. A is the least significant bit, DP is the most significant bit. Here, as you can see here. Okay. So now let us develop a program for this 7-segment display for both common anode and common cathode, and we will see the program using working of this program using Proteus IS schematics. So I'm going to project. I'm creating a new project. Let's create a folder for this. Let's give me the name 7-segment. Go to the folders. Save your project. Pick your microcontroller. I'm going to take 8089C51 microcontroller. So here I am going to create my program within a new document as include h51.h. Save this file. Forgot to save this file. .c with .c extension. reg51.h is the header for all microcontrollers which are 5051. So here I am going to create a main function. Here I am going to create a array for my hex values. Copy this. Let me copy this. Copy. Paste it here. So this is my common anode hex values. Then I'm going to take an integer I and while loop. I'm going to write the program in a while loop so that it can continuously iterate. Here I'm going to write a for loop so that it can go from 0 to 1, 0 to 9, less than 10, I plus plus. Now it goes from 0 to 9. And I am going to take a port 2, that is P2, and pass my x values here. So I. So if I is 0, x values of 0, that is first value will be passed to P2, port 2. If I is 1, on next iteration I will be 1. So F9, that is this value will be passed to port 2. On next iteration it will be I is equals to 2. So this value will be passed in port 2. But I need to take a delay because if we don't take a delay, it will be too fast to see. So here I'm going to take a delay. I'm going to create a function for delay. So this is my delay function. And this is my main function. Build target to check for errors. Target not created. So, I have forgot to add the source group. Add your program to source group first. Add existing file, 7-segment display. Okay. Here it is added. Now build target. 0 errors, 0 warnings. Now go for options for target. Change the crystal frequency. Output. Create hex file. This hex file is used, and again build a target. This hex file is used in Proteus. Now my hex file is created. I am going to my Proteus schematic, and here let us remove my already existing. So now I'm going to pick a fresh. I'm going to pick my 8089C51 microcontroller, and I need a 7-segment display. So 7-segment common anode I need now. So I'm going to take a common anode. Here see red 1 digit, that is 1 digit means 0 to 9 digits. Common anode 7-segment display. I'm going to take this. Now place our devices in our root sheet. Connect port 2 to 7-segment display. 7-segment display. Yeah. Happening there, Okay. No common anode, so I am going to take a power. This is my power VCC. Connect it. Change the crystal frequency 592. Add our hex file. Seven segment objects hex file. Okay. Now play. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Again 0, 1. So it's going in a loop. So this is my common anode. So if I want to create a program for common cathode, the program is same. I all I have to do is change my values. Here I am going to take this. I am going to comment this. Now I am going to take values of common cathode. So these are the values of common cathode. Save. Again, build a target. You will get a hex file again. Go to Proteus. Now change this decimal, 7-segment display to common cathode display. We can't pass common anode values to common cathode or common cathode values to common anode because it will create a mess. We can't identify the values because it can't identify, common anode cannot identify the values of common cathode. It will give us some random displays. It displays some random values which are not even recognizable. 7-segment common cathode. Now I am going to take a 7-segment common cathode. Here you can see this is common cathode. Okay. Now common cathode. Take this. Connect our port to this. Port 2. Now common cathode is connected to not power but ground. So I am now going to take ground. Yes. Connected to ground. Now again dump our hex file. Newly created hex file. Okay. Play. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this is our common cathode. So this is our program for common cathode and common anode. All I changed is I have changed my hex values. Remaining all program is same. So you have seen today, you have seen how to display 0 to 1 values on both common anode and common cathode 7-segment displays. Okay, that's all for today. Thank you very much.